Hi all. In this presentation, I'm going to demonstrate data analytics pipeline in Azure. So for that, we are using home credit dataset, which is present in Kaggle. So our main objective here will be to assess how capable each client is of repaying a loan. So now let's move to dataset. So here mainly from analytics point of view, I will be focusing on these three data sets, which is application train, bureau, previous application, and let me go to the documentation which I have created on these data sets. So these are some of the columns which are common across all the data sets. So let me go through the real life event and map it to the column. So let's say if the client goes to a shop and buys a washing machine on EMI, so you applying for EMI will generate a current client ID or current loan ID. And once loan is approved, it will be recorded as SKID previous. So each client or each current loan ID will have corresponding previous loan ID if the client has applied previously. So this will be one to many relationship. So let's go ahead with our key data sets. So let me start with application train. So so this is our main table, which or you can say base table, which will which we will be considering for join. So we will be joining against it. So let's go through the columns. So as I mentioned before, this is my SKID current, which is unique customer ID for current loan application. So and target is label one. Target label one means the client defaulted on loan, and zero, that means he repaid. And few this is name contract type. So if cash loans are there, that means it's one time. So one time SKID will be generated for it, and once it's closed, it will be passed. But in case of revolving loans, so let's say you are taking loan against credit card. So once you repay it, again you can take against same credit card. So the SKID will be same here, and the loans will be revolving. So once you take, pay, and so on. So let me quickly go to some of the important columns. Let's say name income type, so which I will be using further in visualization. So let's say the it categorizes applicant's income if he's working or pensioner or business is doing some business. So and this name education type, this is education level of the applicant. Let's say secondary, higher education, and so on. Now let me go to my second table, which I will be using is bureau. So this contains credit history snapshot from external credit bureaus like Equifax. So basically, it will be uh, containing history of all the previous loans the client has taken in the past from credit bureau as well as other institutions as well. So basically, the institutions, financial institutions, report their data, loan data to bureaus. So here, SK Bureau ID will be there, which is unique ID in this bureau data set, and which will be mapped to SKID current. Now let's go to our next data set, which will be previous applications. So it also tracks all the past applications before the current loan analysis. But the main difference is from the bureau that this past applications belongs to home credit only. So yes, so this also contains SKID current used to join with main data set and SKID previous, which we explained earlier. And some more columns like amount application, loan amount applied for, amount credit. So these all we will be using in further analysis as we go on. So now let me quickly move to my architecture diagram. So here I am using Medallion architecture. So it will be divided into bronze, silver, and gold layer. So in bronze container, we will be storing raw data, which we ingest. In silver layer, after transforming raw data, cleaning, handling null values, and so on, we will be pushing it here. And gold layer will contain our curated data ready for presentation. So basically, we will be adding some more features to it required for presentation. So let me explain through the architecture diagram. So first, I will be ingesting data from my source. So here in this case, what I did is I uploaded all the data sets in my Git repo, which is dataset home credit default risk. And from here, I will be ingesting data via Azure Data Factory into my branch container in ADLS. And in next step, there will be transformation in Azure Databricks. So I will be reading raw data into my Databricks workspace. And one thing, one more thing to notice here is I am using SQL DB for enrichment purpose. So basically what I did here is I stored this bureau.csv in my SQL DB, Azure SQL, and I will be ingesting directly into Azure Databricks for the purpose of data enrichment. Let me quickly show. Uh, wait a minute. Yeah. So this is my DB, CRDP, SQL DB dev. So this is the naming convention I'm following. So credit risk default project and SQL DB is the resource and dev represents development environment. So here we can see I have uploaded bureau data in it. So this is the data this is the table which I will be using for my data enrichment. Let me close this. Yes, so after transformation, I will be pushing data into my silver container. And from silver container, I will be further reading into Azure Synapse, where I will be creating external table, and in the process I will be adding some extra features, extra columns which will be useful for our analysis, and at the same time I will be exporting this external table into my gold layer. So And of course, I will be connecting using my Power BI to this external table, and I will be creating dashboard for the visualization purposes. So this is my architecture. So now let's start with the first step, which is ingestion process. So here is my ADF where I have created the pipelines. So this is my key vault, which I will be using to securely connect with my ADLS account. So this is my storage account of Azure Data Lake. And here we have all the containers, bronze, gold, and silver. So instead of directly exposing the access key, I stored my access key here in my key vault. I can show it here. So this is my secret access key, which I've stored here. This is for Databricks, which I will be using further while transformation. So let's first focus on this. So I am basically, I've created a link service to authenticate to my key vault. And yes, so using key vault, I will be accessing my data lake. And here you can see secret name, access key, which I showed here. So once this is connected, so this here, it will be my sink and this will be my source. So from here, I will be ingesting the data from my GitHub. So now one more thing I want to highlight here is I've created one more link service. This is for iterating over the JSON input list, which I have created. I can show you here. Yeah, so this is input files.json. So instead of like uh, applying multiple copy activities in pipeline, I will be using for each and I will be iterating through this list. So let me quickly go to my Databricks pipeline. So yes, in this lookup, we will be reading this input files.json list, and we will be passing, let me put it aside. Yeah, we will be passing it to for each loop. You can see here, I'm passing in the items, I'm passing this parameter, and which is the output value of first activity. And inside it, I've also kept one if condition. So here I am ignoring this application test.csv. As I said earlier, we will not be focusing on ML part, so I'm ignoring this data set. Also sample submission.csv and bureau.csv, since we are reading it using Azure SQL. So, and inside this check valid file condition, I have kept my copy activity. And inside copy activity, my source will be, so basically I'm creating here a URL of my data set. I'm iterating through it and picking up this relative URL, which we saw here. And I also have my base URL, and I will be reading data in raw format from this URL. and I will be copying into my data lake, which I have created link service before. And the file name also I will be taking from my input files.json. So this is my pipeline, ingestion pipeline. Now let's go to my second step, which is the transformation. So let's go to my Databricks. So here also I am, and the first step is to connect to Azure Data Lake. So for that, I have created a Databricks secret scope, which if you go here, there's very nice tutorial in Microsoft Learn to explaining how to connect Azure Databricks to ADLS Gen 2. So here I have created Azure Key Vault packed secret scope. So basically what I did is I created my service principal and app registration, and I've stored my secret key to my yes, here in my key vault. So I will be accessing this key vault using Databricks. So for that, I've created one Databricks secret scope, which is mentioned here in step 6. And from there, I will be accessing my Databricks CRDP service principal secret. So using service principal, now I will be uh, connecting to my Azure Data Lake storage. So one more thing I want to highlight here is in access control IAM, I have created a group which is Data Lake contributor group, which role as a storage blob data contributor. So in here, I have assigned 4 members to this group. So contains myself, and this is for Azure Data Factory. This is service principal, which I will be using to access this ADLS. And this is for my Synapse. So now go to my, let's see the transformation pipeline. So once authenticated, I was able to list all the files in my branch layer, and I ingested data, and I also ingested data from SQL Server. After that, I did data profiling and schema overview. Under this, I simply printed schema, display, limited number of rows, and and the null count. I checked the null counts as well in different columns, and I described the summary statistics of each data set. So in this, as I said, I will be focusing on these three basically. So I passed these 3 datasets in this function. So you can see here all the top rows, null count, as well as summary statistics. So now next I did some exploration, and here I simply checked the distinct count of client IDs in these 3 datasets. Here I checked distinct credit active and credit currency as well. So here we can see in credit currency, it's simply written currency 1, currency 2, currency 3, and currency 4. Basically, it's not encoded anywhere where we can say this currency 1 is dollar, pound, or etc. So what I did is I check the counts in each credit currency, and we can see that 99% of the data belongs to currency one category. So what I have done later on is I will drop these all the other columns just to uh, remain consistent in our future calculation as well as to avoid noise. So yes, and this is some just I explored simply this credit card balance data set. So here, although I will not be using this, but yeah, here just to see the behavior of the customer, I listed one SKID, and here we can see the customer has taken loan against credit card minus 48 means 48 months ago, and he has this amount credit card limit assigned to him, and around minus 20, it was that means 20 months ago, it was the last installment of the amount. And yeah, and then he didn't took loan, and after last 11 months he again took the loan. And we can also see the credit card limit is being changed according to customer behavior. So yes, so in this case, this SKID uh, is the classic example of late repayment behavior. So which uh, which is indicated by these two columns, SK, DPD default. So I've listed down data for this customer as well, and we can see. So he made late repayment, let's say by 189 days, 161 days, and so on. So this was just for exploration. Now come to my next step. So here I dropped unnecessarily columns. Basically, I did some feature elimination and retained some key columns. So here I created the function for application train and credit card balance, previous application, and so on. So I will be mostly focusing on application train and previous application, which is my area of interest right now. So I applied this function, and next step I prepared for silver layer, and I did some data transformation. I cleaned handle null values. You can see in bureau, as I told before, since 99% of data is in category of currency one, so in order to keep calculations consistent, I filtered it and I filled null values, and I dropped, let's say, amount credit sum where it was null, so it was only 13 rows. And similarly for application train, I filled, let's say, name type suit if the value is null to unknown. And for some columns, I used medians for the imputation. Yes, so I applied all these transformation functions to this data set. And yes, so here I am, in my next step, I am creating some columns which will be useful later for visualization as well as analysis. So here I created I aggregated on bureau. I summed amount credit sum as total credit sum, total credit debt, and one more column I added is credit utilization ratio, which is very important. So a high ratio means can indicate financial stress or over reliance on credit. That means if the client is utilizing the credit very fast, that means he is financially stressed. That's a good indication, and that's red flag. That means the client is going to default. That's quite a possibility. So similarly, for previous application, I did aggregation. So count star means previous application count for that client. Like, is the client new to our credit home, or if he has taken loan previously? So that feature will tell us, and so on. So in the next step, I joined aggregated data with application train. As I told earlier, like application train, I will be taking as base table against which I will be joining my data. And yes, and at last I saved my data, join data to my silver container in my ADLS Gen 2. So here you can see I've created one folder, applicant profiles. So inside it, it will be stored as Parquet format. So yes, this is the data. Now let's move to our next step, which is Synapse Analytics, where I have created external table. So yes, let me go through it. So first what I did is I created a view. I created view for my silver layer. You can see here the applicant profiles, and I created applicant profiles view for the same. Using this, I created my gold layer data sets. Let me, yeah, so using that, I created first my gold layer view. You can see here. So here I have added two features, basically debt to income ratio as income to credit ratio. So these two will be looking in visualization steps. So here I used application profiles view, applicant profiles view in silver layer, and I created my gold layer view, which is applicant risk profiles. And using this gold layer view, I created external table using CTAS, which is create external table as select. So you can see here. So for that, I have created password and created database scope credential and file format. After that, I created data source, and using these data source, I created uh, my external table and stored it in applicant risk profiles in my gold layer. So you can see here, I've selected here gold. I've given the path as gold container. So if we go back, yes, so here we can see it's stored inside applicant risk profiles. So the steps are properly described in Microsoft documentation. So I followed that only. And later on, I realized that there's some good uh, visualization we can build on top of Silver layer as well, silver layer temp view. So I've created external table for my silver layer table as well. So this I stored here, applicant risk profiles external table in my silver layer. If I can go back. Yes, so here I have exported. So now let's go to our visualization part in Power BI. So yes, so here simply I connected using serverless endpoint, which I can show you here. Yes. So using this serverless SQL endpoint, I connected using Power BI, and I can see all the external tables which are present here in my SQL database. And we can see here in my Power BI. And so let's go to the dashboards one by one. Let me minimize it. So this is the first dashboard which I created, which is debt to income ratio. So I categorized debt to income ratio into the risk categories. So if it's less than 0.2, then it's excellent. And if it is between 0.2 and 0.36, then it comes in good, and so on. So greater than 0.5, it's high risk. So of course, it's like evident that if the customer has low income and high debt, so of course he will be at risk, greater risk of defaulting. So here we can see the distribution. 51.77% comes in high risk, and 43.19% comes in excellent category. So this is one visualization. Second was previous application count. So most of the customers are first time applying for the loan. So here we can see, and as we gradually goes forward in the x-axis, we can see the less number of customers have applied more than, let's say, 20, 40 in our credit home. So that's the insight from this dashboard. And let me move to another one. Here I have plotted the default rate against education category. So here in the education category, we had secondary, higher education, incomplete higher, lower secondary academic degree. So we can see the most number of our clients come in secondary education category, and the more number of defaults also comes in this category. And whereas we can see in higher education, the percentage of default are less. So uh, take the insights like applications with lower education levels are more likely to default, suggesting the need for stricter credit rules or additional screening. So now let's move on to my next dashboard. Yes, so here I have compared against the income type category. So we can see most of the applicants are from working category, and followed by commercial associate, and next is pensioner, state servant, and so on. And this is my default as well. So this we can see it's also decreasing in the same manner. So insights is of course, it helps us to target risk sensitive segments. And yeah, so now let's move to my last dashboard, which is the distribution gender wise. So here I have created filter as well. So here we can see 65% of loan applied by female client and 34% is applied by male client. And again, I can filter by defaulters. So we can see 57% of all defaulters are female and 42% are male. So yeah, these are some of the insights because this helps us to display the proportion of loan defaulters across gender categories, helps in identifying if gender plays a role in credit risk. So yes, this is all the visualization which I have created. So yeah, all the codes here, I have all the artifacts which I have used in this project. I have uploaded in my Git repo, home credit data pipeline Azure. So do check it out. And yes, so thanks for listening to this presentation. Goodbye.